introduce the panel. It's on. Excellent. Hopefully I have panelists here soon. There's clearly a long there. We have one panelist. Hello. Excellent. Okay, perfect.
Hand not here, not in the
Oh,
antenna.
up at the top. Okay. Thank you, everyone, for being here today. We have a really exciting series of speakers across the built environment and the globe. And I want to speak a little bit initially to set up this conversation, to talk about Autodesk and how and why we address decarbonization and work with companies like the ones who are about to speak to forge new relationships and accelerate the pace of change, both in the developed and developing worlds. Then you'll hear from Helen Walter Terranoni from Trane Technologies. She'll be followed by Nigel Tonks of Arup. And then Emily Newmarch from New Zealand and Monica Schrader from Build Change. And with that, I'm going to take you to, this will be our, oh, interesting, our panel. I think one more. There we go. This will be a challenge to my mental structure to be able to do two things at once. And then I will admit, I was standing on the stage behind the podium, which was definitely designed by a man taller than 6 feet. It didn't quite work. So anyway, thank you. My name is Rama Dunajevich, and I'm the Global Sustainability Partner Lead at Autodesk. If you don't know Autodesk, we're a 3D design and make software company. Designers, engineers, builders, and creators trust us to help them design and make the world in which we live. Think about the buildings we live in and work in, the cars and bridges that we drive on, the things that are manufactured in the world, and even the entertainment, the movies, and the games that inspire us. Autodesk has a hand in all those domains. Major societal and environmental shifts continue to remind us that we are living in an era of unprecedented change. One thing is clear: we need to adapt. Our workplaces, our homes, our communities, oh, I'm not kidding, to deal with whatever may come. Next slide. Yeah. The regulatory landscape for corporate sustainability is evolving. There's a global movement toward governing sustainable outcomes. Companies are feeling pressure from customers, investors, and employees to prioritize sustainability now and not later. Autodesk's most recent State of Design and Make report found that 97% of respondents have taken action to improve sustainability. When asked which groups are influential in motivating their company to set and meet sustainability goals, 83% of respondents said customers, 81% said investors, 80% said employees, and 80% said the next generation. 75% said the government. Next slide. As technology and governments accelerate our collective move to a lower carbon future, shift in processes, products, and services become critical. And see approach is a risky one and an untenable one. Research shows that companies taking the most action to address climate change create significant value for their businesses, society, and the planet. Change can be a challenge, but it also creates significant opportunity for better. Autodesk has an opportunity to create positive impact at scale together with our customers. Autodesk is one company, but our platform and solutions are used by millions of customers who design and make products, places, and experiences that impact billions of people. Not many companies have a far-reaching opportunity to actually design and make a better world for all, but we do have that opportunity and that responsibility. Autodesk customers design and make the built world in which we all live. How that built world is made has an impact on everything. From the homes we live in and the infrastructure we depend on, to the vehicles we use and the electronics we rely on, to the media content we enjoy and use. Our solutions span multiple industries, and empower innovations and innovators around the globe. Because our customers have such an impact, we as a company are ideally suited to help design and make the future everyone wants to see. The industries we serve, next slide. The industries we serve have a significant influence on our global community as well as our planet, and hold a vital opportunity to mitigate climate change and create positive impact at scale. Our customers are solution seekers. Being at the forefront of innovation isn't new to them. It's their way of every day. And they see the value in addressing sustainability sooner rather than later, for the planet, for society, and for their businesses. They are taking action, proving it with investment, and making progress on their goals. Our customers are expected to deliver increasingly complex projects on accelerated timelines while balancing trade-offs among cost, compliance, performance, and environmental impact. To keep up with the pace of change, they are accelerating their digital transformation, generating an extraordinary amount of data across multiple tools and systems. This data presents new opportunities. Studies show that digital technologies, if scaled across industries, could reduce global emissions by up to 20%. The only way to measure, manage, and subsequently reduce carbon emissions is with the right data. Data that is accessible, connected, and useful. Despite a growing demand for sustainability information, many find significant barriers in the clarity, consistency, and reliability of data. Advancements in cloud-connected technology and artificial intelligence are unlocking new possibilities to automate tasks, analyze data, and augment creatively, driving efficiency, sustainability, and growth. In fact, 34% of leaders are already using AI to be more sustainable. By connecting data, workflows, and teams, we connect our customers to more sustainable outcomes. I want to give you a couple examples from the built environment. Thank you. The built environment generates 42% of global green CO2 emissions. I think everyone will continue to hear that number. 27% is attributed to operational carbon, emissions from building operations, and 15% to embodied carbon, emissions from construction and the materials. At Autodesk, we're here to support our customers, 3 of whom you'll hear from today, in achieving their strategic business and sustainability goals. We help them unlock the true value of Autodesk technology, enabling them to reach even better outcomes. I want to give you a couple specific examples of sustainable outcomes our customers are focusing on. 1, reducing embodied carbon emissions. Our customers are tackling the carbon emissions associated with materials' entire life cycle, from extraction and manufacturing to transportation, installation, maintenance, and disposal. By considering life cycle assessments and using low carbon materials along with efficient construction and manufacturing processes and techniques, they're making a significant impact. 2, meeting certification requirements. With the current environmental crisis and the growing importance of ESG credentials, minimizing the environmental impact of products and projects is crucial. This means looking at the social and environmental impact throughout the entire project lifecycle, from raw material extractions to production, usage, reuse, and end of life. Increasing circularity and reuse, designing buildings, structures, and products to remanufactured or reused is another key area of focus. Keeping materials and components in closed loop cycle when they can be circulated at their highest value helps achieve this. By working together with our customers, we're making stride to a more sustainable future. I want to give you a little bit of information about Autodesk Forma. The best time to address sustainability is right at the beginning of a project. It's not only the easiest, but also the most cost-effective time to make a real impact. It's estimated that about 80% of the decisions that made at the design phase affect the overall carbon emissions of the project throughout its end of life. And if we can have effect at the beginning of that process, we can make a real difference to the decarbonization of the built environment. That's why it's crucial for our customers to understand their project's environmental impact from the very start of the design process with an outcome-based approach. Autodesk Forma offers a powerful suite of real-time analyses. These tools give teams quick, visual insights, enabling them to prioritize sustainability from day one. In fact, prior to day one. This way, they can ensure that their projects are environmentally friendly right from the get-go. Here's a story about one of our customers. We call this story, "What's Old is New Again." Renovation retrofit is the key challenge around the world. You'll hear quite a bit more about renovation and retrofit from Monica later in today's program. They wanted to repurpose the building to create a functional office space and a sustainable design showpiece. Their biggest challenge was to balance human health, environmental sustainability, and historic preservation. With our solutions, they were able, for example, to conduct wind and microclimate analyses. Among the outcomes, they were able to reduce embodied carbon, meet certification and environmental standards, and reduce material usage and waste. Another story is about the Wright Museum's smart facility. It's a very important institution in the United States. It's called the Charles H. Wright Museum. They wanted to improve their facility maintenance with a digital twin and break down silos with all the different museum departments. I don't think people often think about museums when they're thinking about decarbonization, but temperature and airflow and moisture within a museum are incredibly important features that digital tools can have a huge impact on. So their main challenge was the lack of documentation and data for smart facilities management, smart exhibits, and smart sustainability. Together, we did a scan of the museum to create a digital twin, a replica of their building that could provide insights to their operations for each sector of the smart museum. The museum can now use as much data as possible to improve their operations. They have been able to reduce their operational carbon and protect digital historical artifacts that are very sensitive to temperature and humidity. And finally, I want to talk about this project in Northern Europe, in Denmark. It's a Ramboll project. Henning Larsen and Ramboll aim to design and build an 8-story multi-use building. Their main challenge was finding the lowest carbon design options for a large-scale project using timber as a default structural system. They used our solutions from schematic design through construction and for real-time collaboration. The project succeeded in reducing embodied carbon emissions by 65%, using more sustainable materials, meeting environmental standards and regulations, and improving social outcomes. I think I cut the good. Here's the challenge. The stories I've shown you are the exception rather than the rule. For every customer for every customer project that reduces carbon, recycles materials, creates resilient infrastructure, or helps people harness digitalization, there are many that did not take advantage of technology in this way. With the right approach and application of digital tools, companies can take advantage of the opportunities presented by designing for sustainability. Investing in low-carbon technologies, incorporating renewable energy sources, and focusing on supply chain emissions can all result in meaningful improvements to their emissions and to the business and the planet. And now an area I feel really comfortable speaking about, because I'm the Impact Sustainability Lead, I want to talk about collective action. Currently, the way we're operating all in silos is not going to work. We need radical collaboration across private enterprise, public enterprise, NGO, students, civil society, and it's only through this radical collaboration and transparency that we have the potential to transform the way that we operate and bring down and decarbonize the built environment in an efficient and speedy way. I think many of you have heard over the past couple of days of the kind of collaborations that are happening, whether that's with the World Business Council for Sustainable Development, with the Global ABC, with UNEP, and with across private companies. And we're really excited to be a part of that and helping to drive collective action. I want to wrap up by saying that we need to revisit the overarching goal of the efforts in sustainability in sustainable buildings. Our goal is to transform the built environment from a leading polluter to a leading regenerative carbon storage solution. This means shifting from merely reducing harm to actively contributing to environmental regeneration. By leveraging data, we can optimize energy efficiency, reduce carbon emissions, and use sustainable materials. Imagine buildings not just consuming less energy, but also reducing carbon emissions and using sustainable materials. This approach helps combat climate change and supports healthier, more resilient communities. Let's continue to innovate and use data-driven insights to create sustainable, efficient, and regenerative built environments. Together, we can lead a way in making our cities and buildings part of the climate solution. And with that, I'm going to hand it over to Helen, who does not need to stand on the podium.
Wait, go back up. Oh. Okay, and this
Or you
one's-
can use that,
Yeah,
whichever.
yeah, yeah. Okay. Thank you.
It'll do.
Yeah, it goes right on. Yeah, they've got control. Hi, my name is Helen Walter-Terranoni, and I work for Trane Technologies as the Director of Global Climate Advocacy and Policy. If you don't know, Trane Technologies is the largest heating and cooling company in the world. We're a climate innovator, and our business and brands directly impact carbon emissions, as we just heard from Rama. We've got 42% of the world's emissions from buildings. We've got an enormous footprint from industrial carbonization, transportation also, and we encompass the range of minus 80 degrees, so think Pfizer vaccines, pharmaceutical processing, as well as storage and shipping. We support that. We're the folks that support that, all the way up to industrial heating, cooling and controlling humidity and heating buildings, as well as transport refrigeration. Over 60% of the world's fresh and frozen cargo is shipped in a Thermo King container. We just heard a little bit from Rama about that dual challenge, right? You know, we need to continue to have access to comfort, as well as to fresh food and vaccines in our case, while we equitably lower greenhouse gas emissions across the space. And data is so important in this, and we are so delighted to partner with Autodesk in so many ways around the data perspective. From our point of view, less than 7% of our greenhouse gas emissions footprint come from kind of scope 1 and 2. So at our plant sites and in our manufacturing facilities, it's a small part of our footprint. Our footprint is focused on the customer's use of our products. So that's where we really, we certainly need data at the front end. We use that to develop the hotspot analysis to what to focus on. But on the scope 3, our customers' use of products is where it really rubber meets the road. So a couple of ways that we use data. We use telematics to look at, for example, for refrigerated transport, we look very closely and carefully at how customers use equipment. We can see if a customer has a truck sitting, idling, running for hours and hours and hours before they fill it with their cargo to ship, wasting energy in the process and creating unnecessary greenhouse gases with no benefit to society. So that's one example. Another example, which is more focused on the building side of things, would be, if we think about energy use, right, there's a couple of different ways to think about energy use, right? If we want to reduce the amount of electrical grid that we're going to need long term, we need to think about this collectively, this problem collectively. If peak energy demand stays very, very high, we're going to need to build more electricity for peak demand. If we're able to load shift from peak times during the day, if you're in a hot area for cooling to the nighttime, if you're in a cold area to the daytime for heating, but that's very data intensive, and a good understanding of what's happening, as well as what's happening from a climate perspective, are all very important to a local climate perspective. All very important to understanding and reducing that demand for energy. There's also, Rama talked some about, building design, right? And if we think about retrofitting buildings and reducing the load, the energy load that's needed just overarchingly from buildings, we've heard over and over again here this year, last year, around tripling up on renewable energy and doubling down on energy efficiency. But reducing that energy load is so important for our success in this energy transformation, and data is really the foundational key to that. So just a little bit about us, because I'm going to talk about policy a little bit. Trane Technologies is, we have been reporting our data, through our ESG report for 5 years, so that data has kind of been out there. And again, data and disclosure have been key. Working with Science-Based Target Initiative that Rama highlighted in her slides as well. Having that data available, and again, for us, looking at our customers' data, remember that's over 93% of our emissions and our footprint. So understanding how customers are using our products, understanding how controls are working, and the footprint there is really key to us, and that data understanding is critical for our reporting and refining, like starting and growing, improving and refining our emissions reporting. We are viewed in our industry, from the heating and cooling perspective, as the industry transformer by the Carbon Trust, and Influence Map has rated us as aligning our advocacy with our climate goals. So I'm just going to talk a little bit about the basics of policy. So this may be a fun one for people in the audience that are policy nerds, maybe not the rest of you, but so there's a lot of different policies that impact buildings, like everything. Rama, you talked about like even equipment certification, so that standards development, building codes, regulations, legislation, all of those things are some ways almost a micro control, right, on a standard, to a macro situation at a global footprint. Energy efficiency standards, state and federal, so subnational policies as well as national policies and international policies, local ordinances, and even tax policies and incentives all impact the way that policy development there are so important in the way that these outcomes are created. So we support good policy. What is good policy, right? Good policy is science-based to start with, right? It's transparently developed. It is durable, it follows the rules, and it's implementable, it's reasonable, right? And then it's measurable, right? We need to know that it has provided a benefit to society and that it has done the thing that needs to be done, right? Whether it's measuring climate footprints or some other energy use, right? That measuring feature for policy is so important. When I think about policy, this is just the way that I think about it. Enabling new technologies is very important, right? Make sure that nothing is in the way for energy reducing technologies, new innovative technologies. If we think about building codes and transportation requirements for new refrigerants, or building code prohibitions around thermal energy systems, those are just a couple examples of things that we have been tracking very closely and trying to remove those barriers. And then advancing the uptake of innovative solutions, whether it's the incentives that we've seen around the world, or mandates, building code requirements around energy, minimum energy performance standards. According to CLASP, there are about 70 countries that have energy performance standards. There's nearly 200 countries in the world. Most countries don't have these energy performance standards in place, and so are largely technology takers. They receive technologies, and so they're not using the tool available to them to kind of to stop the influx of high energy use technologies. And then, of course, defending credibility, and that's all on the foundation of achieving innovative results, including that can be documented due to data collection. So this is just a very short summary for a conversation, and And we certainly believe that what we do today, especially if you think about policy development, it can take 10 years to develop a policy, right? And what we do today will create a better, stronger world tomorrow. So thank you for inviting me, Rama, and thank you to the Global ABC.
How's that? Can you hear me okay? So thank you, Rama, for inviting me to come and talk to everyone this afternoon. And my name is Nigel Tonks. I'm a Sustainable Development Director with Arup. We're a global firm of consulting engineers, and we advise in every aspect of the built environment, from the full systemic buildings through to transport, water and energy infrastructure. Three years ago, the UN set ambitious targets for buildings because they account for nearly 40% of the energy-related emissions, and because they offer 40% of the potential efficiency savings that we need to drive the energy transition. The Global Status Report has found that emissions have barely changed despite investment in renewable energy and building energy efficiency. And it's been said that every week our industry adds the equivalent area of a city the size of Paris, and that new construction is outpacing efficiency gains. So we're not on track, and the gap is widening. It's also estimated that about 1% of all that new construction performs any form of life cycle carbon assessments. So we don't manage what we don't measure. This is why in 2021 we presented ourselves with a challenge of assessing our entire global buildings design portfolio and withdrawing from fossil fuels. And Rama's asked me to share a little bit of the journey that we've taken over the last 3 years, a bit of an update on some of the challenges that we've faced collecting that data, that whole life carbon data from our building portfolio of over 1,000 projects. Even in 2021, we were already designing millions of square feet of new real estate that would come online by this first critical milestone of reducing carbon emissions by 50%. So we have absolutely no time to lose for the building, design, construction and property sectors to be serious about achieving net zero. And yet in none of the 90 cities around the world where we were designing those projects were we required by regulation to calculate the whole life carbon of our designs. We didn't know the impact, the carbon emission impact of the designs that we're creating. The reality at the time was something like 5% of our output were projects where we were measuring the impact of our carbon, because we were working with clients that understood this, that were joining us in this race to zero and wanted to know the impact of their projects. So what I'd like to share is just a little bit of the journey that we took following this commitment, and the lessons that we've learned and some of the challenges that we faced. Our scale meant that we have teams working to different international codes and units in difficult political and cultural appetites for taking on this new scope of service and work to determine whole life carbon. There are different levels of awareness. There's the human factor amongst our own staff, different levels of awareness in our own staff, amongst our clients. It's challenging on so many fronts. As it is for our large organization, it's challenging in different ways for SMEs who perhaps don't have the resources to even begin to deal with some of these challenges. Carbon assessments emerged in seriousness in the 2000s, and this lack of maturity creates its own difficulties. Even in our firm, we discovered 3 years ago that across our 90 cities, we were working to different methodologies. We had different regional standards and different guidance. We were working to different levels of detail. And on the data front, the focus of this meeting, there was no consistency in labeling this data that we were collecting, no consistency in the method of storing this data or reporting this data. So this data was, if you like, locked away in the project files, locked away in spreadsheets, locked away in Word document reports where we were explaining to those few clients that wanted to know this what their carbon characteristics were. So we put together a strategy to standardize our methodology for consistency and comparability across our organization, to store the data centrally so that we could go back and analyze that data in the aggregated data and try and draw some insights from it that would help us advise clients on how to remove carbon from their design propositions. And we committed to reporting our findings and sharing our results and insights with industry. So thank you again to WBCSD and Autodesk for this opportunity to share this journey with you. So for capturing the massive amounts of data that Rama was mentioning in her presentation, we set out standard frameworks. I'm sorry, this is a busy slide, but on the right you can just see the complexity of the framework of different points of data that we need to collect. And this is, if you like, just the very top level of that framework. There are levels below this where you need to discreetly identify the different components of data that you have. And you need that model framework so that if somebody's assessing a project in Hong Kong or in San Francisco or here in Baku, that when they present the results, you can compare them side by side. So this is a really, really crucial activity. So we based our frameworks on standards where they existed in industry, but there are lots of, those standards start at a high level. And there are lots of gaps below those standards where you need to develop your own proprietary standard schema for the different types of data that you're storing. And of course, the challenge that we're realizing now is, whilst we had a really good go at this, and this is what we're working to, lots of others in the industry are now doing the same thing, working to their own schemas. And I'll talk a little bit more about that and some of the challenges that brings up later on. So we developed a common digital user interface as well, with carbon factor libraries and a results dashboard and data storage. These are all the technological bits and pieces that you've got to put together to be able to capture data from thousands of engineers in complex design teams. We all know how complex building design teams are, comprising all the different engineering and architecture and special technical disciplines. You need to have a common, simple user interface that people can open up and put their information in, and then that information is stored in a logical way according to your framework, so that you can then go back and read that data later on. And, all of that provides us with the sorts of things that we're looking for. It provides us with a global data set. We've managed to increase the coverage of our projects from 5% to over 80% of our projects, which for us is a substantial step change in 3 years. And from these large databases, we can start to compare projects, and we can start to learn insights, and we can start to draw some of that useful data to advise our clients on reducing carbon. So here is an example of just the average carbon emissions from the different typologies of buildings that there are, which goes to show that, there is, this is tangible evidence now that there is not one size fits all for all the different kinds of building types that there are out there, whether it's housing, science and industry, or commercial property. They all have specific characteristics, and therefore the targets, the emission reduction targets, if we're making a 40% reduction of embodied carbon, 40% of what? 40% of your starting benchmark. What kind of building? What's the benchmark? So this is the useful data that we want to get at. And of course, there are other things that we can start to look at, which is how would a steel solution or a concrete solution or a timber frame solution, how do they compare for buildings of a certain size in a certain type? How do different curtain wall systems compare? What's a good benchmark carbon emission for my building? That's what we want to be able to say to our clients. That's what we need to have good evidence to ground our design recommendations, to make firm design decisions. So onto the sharing point that I made about. So we've shared our carbon emissions data with the Built Environment Database, and this is a publicly available database which is one of several that exist, which is trying to collect data from industry to provide those benchmarks out to others. And those benchmarks are used for things like the Net Zero Carbon Building Standard that we've collaborated very closely on, which has been released recently, in order to provide those benchmark targets. So when we define net zero, and we define what the embodied carbon limitations are to be able to say that a building is net zero, those targets are set by good quality data that are in these publicly available databases like the Built Environment Database. So sharing this data is really important. And the other thing that we've done is we've published in detail the progress that we've made. So if any of this is of interest to you and you'd like to learn more about it, I mean, I will be here for a little while, but we've shared all of our process, the challenges that we've faced and the lessons that we've learned in this report here, and you can download it from that QR code. And just to sort of move into a wrap-up, the challenge now is scaling for consistency and quality. We know that everyone in our industry is now wrestling with this. And everyone's working on different parts of the puzzle, and they're working with different approaches. You know, they're using their good engineering judgment or their good architectural judgment to do what they think is a good sound approach, but there is no consistency between those methodologies. And that creates inconsistency between how we report. So we keep telling ourselves that the lack of data is holding us back, and we can't drive systems change without the numbers. So the challenge for us all is, how do we scale consistently? How do we build trust and improve the efficiency of getting at this data? That will help us deal with compliance. It will help us de-risk and persuade policymakers and NDC writers to put these targets into their national NDCs and their policy and regulation. And ultimately, the data supports better decision making in order to drive the carbon out of the designs that we're producing. So my last thought that I would like to leave you with is where we are now as we continue on this journey. We've realized that we can't do this alone because of some of the things that we've discovered on the way. We have to now do this collaboratively. We have to work with others. We have to get really inside each other's methodology and approaches to come up with best practice. And this is why Arup is supporting the market transformation action agenda, and in particular, Lever One that looks at standards and harmonization of data. The market transformation agenda brings together built environment stakeholders from all along the value chain on the priority challenges that are needed to drive net zero in the built environment. One final example I'd like to leave you with is an amazing piece of work that we've done with Autodesk very recently, and there'll be an opportunity tomorrow where we'll all share some detail on that. But this is where we've been working really closely in collaboration with 5 of our competitors, so 6 of us together, where of course we're in a competitive market. Of course we want to be able to give clients the best data, the best advice, help them make the best decisions. That's the way we all work. But in this piece of work, we formed a trust framework where we agreed to work on a project that was not one of any of our projects. It was provided by Autodesk. And each of us were given the task to formulate the whole life carbon emissions and assess the whole life carbon emissions of that common BIM model that we received from Autodesk. And please join us tomorrow here, I believe, and the time I think is same time, 1 o'clock, where we will be going into a deep dive explaining the results of that. But that really underlines the inconsistency that exists and the importance of working together. So my final words on this is, if you want to go fast, go alone. That's what we've been doing for 3 years. We think we've gone really fast, but where we are now is we want to go far and we've got to go together. Thank you.
All right, like Rama, I am a little height challenged, so I'm gonna pop up here and maybe use this microphone, if that's all right. Yeah, that seems to work a lot better. Oh, thank you, Rama. You're an angel. So I would love to talk to you a little bit about how we are using data in an informal housing environment. So Build Change, we are a nonprofit social innovator. We have been working for 20 years to improve the lives of people living in vulnerable housing worldwide. And in our 20 years of impact, we have made 1.4 million people safer. We've protected $5 billion in assets, and those are assets held by those homeowners. We hold no assets ourselves, and we have been able to improve the lives of people living in these houses. So, like I said, I really want to focus this presentation around the question of how, in an environment of informal housing where data is already really scarce, do you efficiently and effectively capture data to inform resilience design? So that's what I'll be talking about a little bit today. And in order to do that, I wanted to provide a deep dive into one of the tools that we use to do that, BC Tap. So BC Tap is our Build Change technical assistance platform. And what it really is an end-to-end solution that pairs technology with subject matter expertise to take resilient housing programs to scale. What does that exactly mean? It is a one-stop shop. If you have been around Baku and you've been talking to the locals, you know that they have this thing called the Asan Center, the Easy Center, which sounds like a dream, honestly, because it's a one-stop shop for all public service. You can get anything done. You can get like passports and various like bureaucratic things. This is our one-stop shop. This is our one-stop shop for informal housing, design, and implementation. And we have been using this in 32 countries. And what it really is, it's a digital platform. It is 80% normalized and 20% customized, meaning that we have the ability to adapt it to different markets, to different clients, to different needs. And a lot of stakeholders use it across the housing value chain. So homeowners are using it, and I'll show you how. We have microfinance institutions and financial entities using it to disperse loan, understand what loan packages are available to certain homeowners and disperse those loans. We have engineers and designers using it to understand what kinds of resilience measures they need to undertake in order to build resilience among these homeowners. And we have ourselves build change as we're providing the systems change and the technical assistance throughout the process. And the way that BCTAP works is along a 6-step value chain. So we do the information and data collection, sharing, design. We finance the homes via this platform as well. We build, and then we report, and we have the measurement frameworks as well. I'll talk a little bit just about the design aspects and how do we deliver resilience through design. And when we're talking about design in the markets that we work with, it's often along 3 tiers, and that's ascribing to a level of complexity. So tier 1 really focuses when the design aspects are at their least complex. So it's standardized across houses, you understand what kind of house typology you're working with, and it's relatively straightforward in terms of what kind of design considerations need to be integrated. So when tier 1 is deployed, what BCTAP does, homeowners have integrated, they've taken pictures of their homes, which I'll go into a little bit later, but they've taken pictures of their homes, you understand what kind of resilience measures they need, and what BCTAP does is that it shoots out for you a scope of work, a bill of quantities, and construction details. So you understand, and most importantly, the local construction sector understands what kind of work needs to be done, and the homeowner understands what kind of financial investment do they need to undertake, and what will deliver resilience for their house. Tier 2 is slightly more complex. In comparison to tier 1, it adds the ability to quickly develop and use digital floor plans. And so in this step, we issue not just the first 3 items, but also floor plans by which we use Magic Plan to create those. And then tier 3, as you can imagine, is the most complex. And this is where our partnership with Autodesk has really come in. And we've been happy to partner with Autodesk for the last 10 years in order to undertake this work. So this is when houses are unique or particularly complex. Keep in mind that a lot of the houses that we work with, they're self-built housing. These are not houses that have been built under the guidance of engineers or architects. These are houses that have been built by the homeowners themselves with the materials that have been locally available, with the best expertise that they have been able to ascertain from their own experience, from their neighbors, from some friends who do construction. So this is their unique home. And so what we have done in the design phase is to not only issue the floor plans, but also do design automation and also use Revit for BIM modeling. And this really allows us to understand the level of complexity in these houses and understand the resilience measures that need to be undertaken. And just to give you an insight into what this has meant in terms of the local design process. So when Build Change first started out, we were doing all of these calculations by hand. And it took our team of 3 to 4 people approximately 4 to 5 days to undertake this process by hand. And I'm talking like calculators, I'm talking like basic Excel spreadsheets. It was quite a long time. Now it takes one person 3 hours to do this whole process. And that is a result of using these digital platforms and using these tools in order to do more effective modeling. That means that we're able to reach a greater number of homeowners through our work. It means that there is more accuracy because we are employing a fully digital platform. And it means that there is a clear data capturing mechanism because we understand these floor plans. We have these floor plans now digitalized, and we can share this learning across projects. We can share this learning across countries. So this to us has been an immensely effective mechanism for improving efficiency, accuracy, and really taking resilient housing programs to scale. So that's just a short summary of the differences of how we use BC Tap, but I also want to show you a little bit on how it works. So how does this process happen? So the homeowner will start by taking photos often and inputting essential information about their home into the platform. This can also be done offline. We work in areas where there is not huge internet penetration in many cases, and so they're able to capture all of this data and keep it on the app, and then when they've connected to Wi-Fi, it gets uploaded to a server. They're able to use these digital tools, and ultimately it gets transferred to Build Change so that we have an understanding of what's going on, and that's when we undertake the scope of work, bill of quantities, construction details. And we're working with stakeholders across the process the whole time. And so in many cases, we're working with government institutions who need access to this information in order to effectively disperse subsidies on resilience building measures. So they understand, okay, this homeowner is eligible for a retrofit, and they're eligible for a roof repair, a roof replacement. So they're able to use that data, see that data, and issue a subsidy accordingly. The same principle applies when working with microfinance institutions. A lot of the homeowners that we work with are incrementally upgrading their houses. They're not doing all of the repairs at one time, but rather in pieces. And so they are able to take out loans that are appropriate to the interventions that they have. And I wanted to quickly talk about a couple of cases where we have deployed this technology and where it's working. First, in the Philippines and in Indonesia, as I mentioned, we're working with microfinance institutions. We have deployed a custom-built data collection app to perform home vulnerability assessments, and then we have the scope of work and cost details. We have also, in this case, because it is microfinance, there is loan selection opportunities for the homeowners to understand what kind of financial investment are they undertaking and what benefits does that deliver to them and to their house so that they are reducing their vulnerability. And to date, we have dispersed 1,300 loans for home strengthening across the Philippines and in Indonesia. In Dominica, in the Caribbean, we have also been partnering with the local government to do post-disaster reconstruction and overall resilience building measures. And so we built this custom data app, and we worked very closely with the government of Dominica to understand what subsidies homeowners were eligible for and overall do not just the subsidy disbursement, but also an aspect that I haven't talked about yet is quality control and assessment. So understanding that the subsidies that were dispersed were used in the manner that they were intended to be used, and that there are quality controls in place to understand that, yes, these resilience building measures are being delivered. The homeowner is now living in a safer home. And then lastly, in Colombia, we have been working with the city level government on a program called Plan Terrazas, which is aiming on seismically retrofitting houses, but also building second stories for urban densification. And we have been able to create 3D models of existing buildings through the use of MagicPlan, Revit, and DynamoScripts. And we're, in this program, we're not just focusing on structural retrofits, but also in integrating habitability improvements. What kinds of improvements will make homeowners and people living in vulnerable housing more, better lives? Do they need an extra bathroom? Do they need a place to put their home-based business? Do they need another bedroom for an additional child? What is it that's going to make their lives overall more pleasant? And so we've been able to integrate those measures as well. So BC Tap for us adds value for everyone. It's transparency for funders, it's efficiency for project teams, and it's quality and safety for homeowners. And I'm very happy to work with a group of engineers. I myself am not an engineer, but I'm happy to be able to shine a light on their work because they're doing really incredible work. And they have been working to develop these custom platforms to really deliver on what governments and financial institution needs, and more importantly, for what homeowners need in order to make these resilience building upgrades to their homes. It reduces time and costs. It is now, as the result of using this technology, as I said, it's, the startup phase is a lot faster. We're also faster in home assessments. We're faster during the design phase. And it's also resulting in overall efficiency of our workforce. We have to do 33% less trips to the field, and we all know that flying generates carbon. So that is also important to today's discussion in that, it is enabling us to more effectively deploy a remote workforce so that we can provide this assistance and not necessarily need to be going on planes all the time. So thank you. Oh, yes, that's right. We're scaling it up. Feel free to learn more about BC Tap, and thank you so much for your time.
Can you guys hear me? Cool. Okay, so, and then I can see it down there as well. Amazing. So kia ora, I'm Emily from New Zealand, and I work for a company called Warren & Marnie. We're an architecture practice that has 8 studios in Australia and New Zealand as well. And I lead sustainability, which I'm really excited to talk to you about today. So the topic of my talk is going to be about data-informed design, and I'm really passionate about the role architects have in a sustainable future and owning that responsibility earlier in the project to lead with sustainable solutions and respond to the need that we've got. This is our climate commitment. This was set up in 2019 to be aligned globally with the ambition to reduce emissions from the building and construction sector. We're really proud to say that this year we measured all of our projects for embodied carbon and reported on those internally to our board and stakeholders, and we are now working to do the same for our energy targets. The work that we're currently working towards now is to be more transparent and harmonise these efforts around measurement with others in the industry. We recognise that this sort of one part of data is one piece of the puzzle, and that it all needs to come together. So we're really keen to get a collaboration on that. And so what I'm going to be talking to you guys today is about data-informed design, and these are 4 actions I'm going to run through quite quickly on how we do it and how we think that other architects can also learn and do it too. So starting off with responding to the local conditions. In New Zealand and our part of the world, we're a little bit different. So a lot of countries are targeting an 80% renewable grid, and we're already there. This means that our relationship between embodied and operational carbon is a little bit different. We have a really small footprint from energy because our grid is so heavily renewable from the hydro networks that we already have. And so embodied carbon for us is a really big priority for the projects that we do in New Zealand. But in Australia, it's a very different story, and Australia has one of the highest carbon grids in the world. And so knowing what your local conditions is and knowing where your country sits in terms of its grid factor, that Go Electric message can look quite different in terms of the strategies that you set up in the beginning of a project. So we look at previous projects and swap them between countries so that we learn and make appropriate decisions on what the right starting position is. The next one, which has been a big message from this COP and previous COPs, is about avoiding fossil fuel use. How it sits within our approach is it's one of our top 3 things that a project can do. And thinking about what I've just shown you around different grid factors, switching away from fossil fuels looks different in Australia and New Zealand. Here is a project in Australia. This is La Trobe University. This is a sports facility. And shifting away from fossil fuels wasn't just plugging it into the grid, because we know that that grid is high carbon and largely linked to coal use anyway. So what we did on this project was installed solar panels, and the solar panels there exceed the use of that facility itself and help support the rest of the campus. So thinking about these projects as part of a big network, and what a building that is largely low and flat for the typology of a sports facility, and how that can help support all of the other projects in that space. Another one, which is Waimarie, which is Lincoln Science Facility. This is in the South Island of New Zealand, and earlier this month won a Global Architecture Award in Singapore, or a WAF Award. Lincoln University had a coal boiler that fueled a lot of their campus, and that was a big target for them, was to shift away from that. And so what they have done is made this building all electric, and that was a decision led by the client, and we empowered by that, we delivered that. And also the project also has solar panels as well that help shade and reduce energy. But shifting away from coal looked a little bit like this. So the grey bar is the campus's coal use and the emissions from that across their campus, so just over 4,000 tonnes per year. If this building was to be coal as well, it would add just under 3,000 tonnes to their capacity for coal use. So it would push them further away from their target. By shifting to electricity, and this is in New Zealand, so a low carbon grid, it reduced the carbon emissions from the project by 92%, which was a big win by just one decision, and so we're really proud of that. The third one is designing with data, and this one I'm really passionate about and quite excited for. We do this in a number of different ways, but one way that we're doing in week one of a project is by simulating rapidly a lot of the different energy opportunities in a project. So this one was a project in Wanaka where we simulated over 600 different scenarios overnight to give the architect and the design team the ability to navigate through those results rather than giving them the solution and saying you need 50% solid versus glazing on the facade. Here is all of the different options, and these are sliders that allow the design team to find the appropriate pathway. And so these were two pathways that the design team identified that they wanted to explore, and these pathways for a light and heavy facade transferred into the aesthetic of the project. And so they started then exploring what are these data around energy use can tell us about the way that we can then drive the aesthetic of the facade and how that might look. And then the fourth one, and I am powering through this, is building with data, and this one I see on a lot of the projects that we work with, but one of them that I will share with you is about Archives. And Archives is a project in Wellington that is for our government. It is a very seismically protected building. It has base isolators in the bottom of it, and these base isolators allow the ground to move in 1.5 metres in any direction. It's also, being an archives facility, really important that its envelope is quite strong for energy use as well as thermal shock protection. So the solid parts of that building there are very airtight. The building shifted away from gas, which meant its overall carbon emission reduction was 80% compared to a business as usual scenario. But because of that airtightness and the extra investment in materials into that envelope, the building can lose power, and it won't lose more than a degree in 48 hours, allowing a generator to start up and protect the facility and not lose our national archives. But this wouldn't have been possible without being able to design with data and then build with data. And so this Revit model is one of our biggest and most intensive Revit models that we have. And the way that this has enabled the project to not just have better records of its materials, but know where things go and will need to go. So this is a collaboration with all of our consultants and design team. This project has brought together everything, and they've gone through something like 80,000 clash detections before this thing started on site to test and test and test again to make sure that they know where these energy machines are going around, the mechanics, around the fire, everything has sort of been brought together. And so if this plays, which it might, it may not, what they then do on site is they use this model and they overlay it with a position on site so that they can navigate and look to see how things are being installed, so that we're not just designing and making sure that we're modeling in this way, that this project has been installed and is functioning and is going to operate in the way that is predicted to do so. And so I have powered through, but my last message to leave you guys with is we need to work collaboratively to help the market move forward, measure consistently to enable comparable results, and design with compassion to ensure that we're connecting meaningfully with the people and places that our projects impact. And sort of to leave with the way that we sort of say it in New Zealand is he waka eke noa, let's do this together. Thank you.
So I wanted to, I don't know if we have time. The thought was we might be able to come back here if there were questions from the audience and kind of answer them, or we can hang around in the area and answer questions in situ as that happens. But one of the things that I find so exciting about these presentations is that it takes what seems theoretical in the conversation of like, what do we need to do, to what are forward-thinking, creative, innovative companies doing today? And to a fault, every single one of you talked about how data was transforming your ability to work, how you're now able to collaborate, how you're now able to scale, and the effect that you're having across countries and different zones. I mean, what's incredible to me is the number of different kinds of housing. And I liked Arab, that thing that you had. I hadn't thought about that before. Like each building and what are which kinds of buildings are creating the greatest emissions. So it seems that through data is providing the ability to scale, the ability to collaborate, and then, of course, the most important thing, the ability to decarbonize. So I don't know if there's more questions from the audience. We can kind of come up here, or it's up to the audience. Were there any questions on any of the presentations? I do want to give a round of applause to all the presenters, because we make tools, and to see those tools in action and what everyone's able to do with those tools is just so exciting and inspiring. So thank you to all the presenters for today. But I don't know, no one kind of made any. I have a question. Did any of the presenters have questions for each other? Go for it, Helen.
I was just thinking about some of these tools, Rama, and like the implementation of the IRA, the Inflation Reduction Act, and how they might benefit from looking at deep decarbonization of commercial buildings, or of residential buildings, and then this design work for resilience. I'm not hearing this data conversation in those conversations, right? Like it's a lot of times people implementing those programs are more social focused and less data focused. And I think that there's some introductions to be made that could really benefit and speed some of this implementation along. So, thank you for those great presentations, very enlightening. And from a policy implementation perspective, I think that these tools just could be priceless. Not really a question, was it?
No, it's good. Did anyone else have any questions in the audience? Okay, well, I'm going to give a huge round of applause. Super inspirational, incredible to see the work that's happening and the work that we need to do, but it feels like I will, as an American, I'll readily say I haven't been in the best mood in the last couple of weeks, and to hear the momentum and the dedication and the determination across political spectrums to really make a difference, to decarbonize, and that's working around the world is just fantastic. So really thank you to the panelists. Yeah.
Okay, hi. I'm Danielle. I'm from University of Miami. I'm a PhD student there, but I'm here representing the Miami-Dade County Office of Resilience, specifically the Chief Heat Officer, Jane Gilbert.
Wait 1 second. Mm-hmm. For those who are listening in the audience, that's in Florida, a state in the United States. Go ahead.
Yeah, thank you, the U.S. Great, amazing presentations, really inspiring, especially for a student. My research is in energy efficiency in air conditioning, so the data is really important to us. So we spoke a lot about data, and I'm just wondering about if it's publicly accessible. I feel like it was, but where are these places where universities can acquire this data if we can?
So you won't meet, you've got people actually in the audience who can answer that. And also, I will call out Helen. You will not meet a better refrigerant nerd on the planet than Helen. So if you have questions, she's your gal. And then to give up, the data availability, we have both ICC and Rick's here. But I also will say from an Autodesk standpoint, we have a 4-step approach. You can have a mindset, tool set, and talent. And all Autodesk software is free to all students, all educators, all educational institutions everywhere in the world with training. So there is that opportunity now. It's not the access to the data, but I don't know. I think hand the microphone to the person in front of you or to a person to the right, and they could answer your question about.
I will say we definitely use Autodesk.
Yeah, so definitely appreciate the question. At the International Code Council, so we recognize the challenge of the availability of data, particularly across sort of various different life cycle stages and various different disciplines. And so we've actually recently launched an effort with Standards Australia for a universal data protocol to sort of allow access and transferability of data to really help sort of address the challenges, recognizing sort of the need to collaborate and have information available across the entire sort of life cycle of buildings.
And then just building on what Ryan said, and Nigel actually pointed to this, which is in the UK we've created the Built Environment Carbon Database in partnership with other bodies, which looks at things at an asset level. Well, it puts in data points at an asset level, but also at a product level. So one thing that we want to do that is scale it up, and I think the discussions that we've had across the week is how do we have open data sources, open APIs, and actually share that, which I know there's several different organisations looking at that, and we're one of those. So it's not all publicly available at the moment, and there's lots of databases in different countries. Denmark has a great one. We've obviously got one in the UK. There's other ones opening up, but it's actually just how do we start? How do we make sure the data in there is comparable and consistent? And also, how is it open and readily available to the public, like you said?
Thank you.
Excellent. Well, a huge round of applause for our panelists. I really learned a lot today. Thank you.